Demand for AI is infinite. And what if AI proves the Riemann hypothesis and nobody looks? These are two one statement, one questions which are crucial to our investment in Tesla and NVIDIA, and crucial to the idea that SpaceX and Tesla eventually should merge depending on the price. We're going to another episode about the actual price that we think this merger should happen. But let's not talk about this now. Let's focus on the concept. So the demand for intelligence is infinite. And what if AI proves the Riemann hypothesis and nobody looks? These are two related questions. They answer the answers to those questions, or the answers to the questions that they underlie. So the demand is infinite is the answer to a question, and the Riemann thing is a question. But they both have a very peculiar significance. Let me start with the demand side of things. In order to justify a merger and massive investments in orders of magnitude more AI data centers and training and power consumption that, according to Elon Musk, should happen in space, whether, by the way, it happens in space or not, is not even that important right now, because in principle, we can just talk about the idea of scaling AI at a much, much faster pace and asking ourselves, is that even worth it? And there comes the question, what if AI solves the Riemann hypothesis and nobody looks? And the answer to that question is, well, that would be a huge waste of resources. And the question then is, like, are AIs going to do things that we even realize? In other words, we could see a proof and not understand it, or we could not even realize that the thing proved the Riemann hypothesis. Now, why that's relevant is, of course, the AI could then use that proof as a validation for a next level of reasoning and then come up with new ideas. But fundamentally, and this is the key, we humans have to make AI use for ourselves, and AI will do things that are useful for ourselves. We have to act as investors, whether we are real investors like we are Orange Capital Partners, or whether we are entrepreneurs or even people with their jobs. Everybody is an investor now, because what we humans are doing is we're putting resources to work, the resources being intelligence that will serve our needs, and that's how we're going to monetize this new AI economy. This is the Not Even Wrong podcast. It's February 9, 2026. This is Telco. For the year, we're down 6%. The market's up 2%. We're underperforming by 8%. So let's talk about the intelligence part first. Why is the demand for intelligence infinite? In order to understand this, and I'm leaning on a tweet by Naval that he posted recently, X-post actually, not a tweet. The point being that demand is infinite, because in order to understand the statement, I think you should go back and read Popper and David Deutsch. I think that's where Naval's coming from. Shout out to Naval, by the way. Because the way we understand intelligence in a Popperian way is it just solves problems and gives us solutions that are better than existing solutions. And it does that in a way that the incumbents don't use violence against us. So that applies to moral philosophy as much as to engineering, as much as to physics or politics. So that's what intelligence is. It is predicated on knowledge, and new knowledge begets new problems, which beget new knowledge, and therefore this is a flywheel which infinitely grows. For example, if we have the knowledge of building lithium-ion batteries, then we need to generate knowledge of how to mine lithium. If we mine lithium, we have to generate the knowledge of how to recycle lithium. Hence, you can see where this is going. Like every time we have a new technology, which means new knowledge, we have to generate new intelligence, which is solving problems that arise from that new knowledge, and then generate new knowledge, and that's how we build. And this is a flywheel that will exponentially grow, and that's why we also need infinite or near infinite compute to generate all the iterations which are necessary to get to that knowledge, because knowledge is a function or a result of iterations. That's what knowledge is. So when we come up with a Pythagorean theorem proof, the way we do that is we iterate. We try, we fail, we try, we fail until we actually get to the right answer. So knowledge is predicated on conjectures. Conjectures can be falsified, and if they can't be falsified, then they turn into knowledge or theory, and then we build on that, and we obviously have new problems coming from that. So we, for example, solved the dark body radiation problem with the Planck experiments, and then we created a new whole field of quantum physics, which then requires new knowledge and new intelligence to solve all the problems that arise from there. So therefore, we believe that knowledge has infinite demand. Actually, it's not that we believe it, we're certain about it. And therefore, we also think that with the right algorithms and implementations, data center AI, or an AI which can harness a massive, much bigger amount of energy than we are harnessing today, would be beneficial and also monetizable. Now, the monetizable part, that's going to be the other part of this episode, the Riemann part. I'm going to come to this in a second. I just want to stay with this. I really want to bring this point through. Like, think about it this way. Like, you cannot, like, knowledge and intelligence are not finite quantities. By the way, there are other sectors of our economy which have similar characteristics. For example, transportation or communication. Those are sectors or services that also have at least near infinite demand, because they create their own demand. Like, the more transportation you offer, the more point-to-point transportation you have, the more need you have for even more transportation, because now you're changing the way you're doing business, for example, and you need more logistics and more just in time. And with the more just in time, you're creating more demand, and people change the way they move and maybe live in other places, so they commute more and transportation has at least begets its own demand. Communication is the same way. If all I can do is one phone call per month, like it used to be 40 years ago, an international phone call from California to Switzerland to call my parents would cost me a lot of money, so I do only once a month. But if I can talk every day, then there's back and forth, there's new problems arise, new communication reasons arise, and we therefore have a lot more communication. So maybe they're not as infinite, they don't have the same characteristic like intelligence, but they are similar, and that's also why these industries are so interesting. Now back to intelligence. Again, I encourage people to read Popper, and particularly David Deutsch, to understand this concept in epistemology that humans are the source of intelligence that then begets its own problems, and that we are now expanding that reach with artificial intelligence. In other words, we're just using machines that can iterate at much larger scale and also absorb a lot more energy than we can, and therefore also do a lot more work. So this is, for example, comparable to the difference between a bird and an airplane or a fighter jet. The airplane and the fighter jet can obviously fly the same way a bird flies, but they fly very differently and they solve very different problems. And in many ways also much more interesting problems than what birds solve. Now, birds also have their value, and they have certain qualities that those two other flying objects don't have. But clearly, these new machines have capabilities that nature hasn't been able to come up with. Now, the humans have been able to accelerate this through iteration, which we call, that's what engineering is iteration. And therefore, the way we see the value chain is the following. So we have knowledge, and the knowledge creates problems. So, for example, you have the knowledge of building a AI data center, the concept, the conjecture of how to do that. Now you need to iterate. You need to iterate in the real world and also in simulation of how to actually execute that, how to build solar panels, how to bring them up to space, how to connect them with AI data centers, how to train these things, and how to bring all these things back down to earth, and how to make them useful, and how to monetize them. All these things are problems that can be solved, and all of these problems can be solved with additional intelligence, and you iterate around, for example, the way to make more efficient solar panels. You harden the solar panels against radiation. You harden the chips against radiation. You obviously iterate around the engineering of Starship, so you can bring these things up there at a lower cost. You then build the things. You generate new algorithms that can absorb 10, 100,000x more energy, so you don't need to be energy constrained anymore as you are right now. You have to also build radiators. You have to iterate around there. So all of these things can be done with AI, with technology, with intelligence. And once we solve that problem, we have these AI data centers. We have let's say 1,000 times more compute available to us. We therefore have also more opportunities to generate new knowledge. Also, we don't even know right now what kind of knowledge we're going to have and what kind of problems we're going to be solving. But one thing we know, and that's the trajectory that we're on, that's that we exposed at Naval, and I think Musk agrees with that, is that we have infinite amount of intelligence and therefore infinite amount of power, and therefore we can go Cartership 2, Cartership 3, which for us humans right now is infinite. Of course, at some point that will become maybe not so infinite anymore, but that's a different conversation. So having said that, now let's get to the second point, and that is where is this all going? So if we have this amazing intelligence that is coming, what does that mean for humans, and how should humans react to it? And I think the question, what if AI solves the Riemann hypothesis and nobody looks? I think it's an interesting question because it puts us in a position where it's kind of like the tree that falls in the forest and nobody hears it. Does it still fall? Is it still relevant? Well, yes, it falls, of course, even if we don't see it. But in this case, if we have a Riemann hypothesis that's proven and we don't understand it or don't look at it or we oversee it, it's still there. And it can be used by other AIs. Maybe other AIs will actually capture it and solve problems. The problem, though, I think, that could arise from a situation like that is that those AIs that start generating new problems and new iterations and new solutions to problems that are not relevant to us anymore. And then the question arises, okay, how will those AIs monetize us? Now they can maybe solve problems which are native to AIs. So maybe the Riemann hypothesis that we haven't even noticed can be used for the AI for new conjectures, new reasoning, that then go into a direction that is not familiar to us. And they could still be monetizing maybe those things. But the question for us humans is, and I think that's where I see the role of humans, at least in the next few generations, is we all have to start thinking like investors. And what that means is investors are allocating assets with a particular return in mind. And we're allocating these AIs to do work that gets us a certain return. It needs to be monetized. You have to be thinking a lot about the use cases. You have to be thinking about the problems that could arise from the current knowledge and the current intelligence available to us. And those problems then can be monetized and therefore turned into economic value. That's where I see the future of human labor. It is generating ideas for how to monetize new problems and generating new problems and ideas about new problems and new problems to be solved that can be monetized. So if we don't see that there is proof for the Riemann hypothesis, then there's two reasons. One is maybe we just haven't been able to understand it. We don't even know what's going on. Or the other option would be maybe the Riemann hypothesis itself is not very useful. And other things, for example, if we could prove another mathematical entity that could be used to generate a much better starship at much lower cost, or a much better battery, or if we could maybe use techniques to dry coat 4680 even faster and make the 4680 battery production 100 times cheaper, and therefore increase the volume and have a lot more batteries available for energy storage and EVs, then we can actually monetize that, because usually, what does it actually mean to monetize something? Monetizing in economics simply means you can offer something at lower cost and higher value. That's when you're able to monetize something, and that's been proven across the history, at least modern history of capitalism. I exclude things like subsidies and government interventions and things. So if things take the natural turn, it's usually you come up with something that is much, much, much lower cost and much, much higher value. So a self-driving car is a much lower cost than a regular car, and it has a huge amount of value. By the way, lower cost because not just the car itself is a lower cost like a cybercab, but also much less accidents, lower insurance costs, lower wear and tear. So let's call it, maybe the costs are, 2-3 times less, and the value is orders of magnitude higher because you have now this huge opportunity to, for example, do other things while you're driving, or at some point also have the car drive itself and therefore pick up your kids from school, things like that. So we can go back to Amazon, we can go back to Rockefeller, we can go back to Disney, we can go back to, I don't know, Ford, whatever, Vanderbilt building trains. Every time they did these things, lowered the cost and increased the value of the service at the same time. So that's what monetizing actually means. I think the role of the human, whether it's you, one person, looking at her job and actually deploying AI agents for her job, or whether it's an entrepreneur or actually an investor who deploys money, in all these cases, we're all doing the same thing. We're deploying assets to work. So work will be done by the AIs, and it's our job to deploy them, to orchestrate them, and to generate returns. Now, you might say, well, an AI can do that too, and that's true. As soon as an AI can do that, it's a bit, I always use the analogy of driving. If the AI is better than driving than you are, then you shouldn't be focusing on driving. You should be focusing on other things, for example, of how to, take better advantage of the time while you're driving somewhere. And if you want to do a service, you can do things like make people feel better in the car, like Cybercab is designed for. So there's other things you can do because the driving itself is not anymore a competitive advantage because for the human, because the machine can do it. And the same way you could think about this in the future. So back to the question, the Riemann hypothesis, I guess if something is not relevant for humans, then it's not monetizable, at least not in the human economy. And whether there is an agent economy or not, let's put that aside for a second. Let's just talk about the human economy. There's plenty of things to do in the human economy, at least for now. So as an individual or a company or an investor, again, to me, it's all the same thing because what you're really doing is you're deploying AI agents to execute tasks which are monetizable. Now, those tasks might be directly monetizable, or they are just the first step towards a higher order monetizability. For example, you need to generate certain types of intelligence to then generate other types of intelligence. And then on top of that, you can, so it's kind of like Elon Musk said, like a video game where you need to get to a certain level, the next level. That depends on the actual case. But fundamentally, I think the mindset of a human person has to go from task towards job. That's I'm paraphrasing Jensen Huang. Shout out to Jensen Huang. So if your task is to drive a car, you're going to be outperformed by AI. But if your job is to make people feel good while they're going from A to B, if your job is to make people safe, again, feel good, and they're ready to pay for that, which I think a lot of people are ready to pay for, to feel good about, for example, a trip. And if they land at JFK in New York and they then get a very good experience in terms of being transported from the airport towards home, then that they're willing to pay for that. Maybe in the future they will also pay for services such as having your spreadsheets ready while you land and ready on your screen in your cybercab and so on and so forth. So there's a lot of additional things that can happen. We cannot predict knowledge and intelligence, but one thing we know for sure is that if we can do something at lower cost and higher value and monetize it in the human economy, then that will, at least for foreseeable future, have a lot of traction, and that's where we see the role of humans. So to summarize, the idea of building massive amounts of data centers in space is a good idea because we believe intelligence is infinite, and therefore getting access to much more energy at this scale is worth the while. We also have the technology, we're able to do it, and we can actually use intelligence that we're generating through this new type of a data center, at least for now on Earth, but then in the future in space, to even improve the space-based technology by improving Starship, by improving hardening of chips. coming up with new chips, coming up with new algorithms, coming up with new ways to do inference. And then with those, we generate new problems. And therefore, this is a flywheel or an avalanche, actually. It's more the avalanche effect, where it just builds on each other and grows and grows and grows. And it's infinite. There's no inertia there. There's no centrifugal forces, none of that. Actually, there are centrifugal forces, but there's no inertia like in an avalanche, which fortunately sometimes gets to a halt. Here, it just keeps going, at least for the foreseeable future. Foreseeable meaning a few generations from now. And then the question of the Riemann hypothesis, nobody looks, is sort of a metaphor for the idea that intelligence that we don't realize is even intelligence is not going to be very useful for us in the human economy, maybe in the Asian economy, but not in the human economy. So we need intelligence that we can identify as useful, and the agents will be geared towards that kind of intelligence, because that's, at least again, right now in the human economy, that's the monetizable intelligence. Thank you.